All right, good morning, everyone. Let's go over what line integral is. Okay, without further ado, let's do it. Okay, suppose you have something called a path in a space. So what does that even mean, right? So let's say you have um, y-axis, then you have x-axis, right? This is x, this is y, right? You can have x, y, z too. So the idea is the same. And then let's say that you walk along a path like this, right? So the path will have a starting point, the path will have end point, right? And it has direction too that is go from here up to there, right? Usually we're gonna give it a name and we're gonna call it C. Okay. So let's say you walk along this path. Okay. No problem. So what? Right? The thing is, once you have a set of points that you have certain direction, you can do integral on them. Um, even when it's like on x-axis, or we have like this space that we have area, we can integrate, right? This thing too, we have a path and we have direction. We can think of it as like it has like some value along this point, and then we want to integrate, right? That's what we're gonna do here. Want to integrate a certain function, so we're gonna call it f, right? And we're gonna do it over c. The thing is like there's so many d we can do, right? But that's the basic. We have a path in a space and we want to integrate over it, right? Um, so let's go over some basics. All right, line integral will consist of three parts. All right, so I'm gonna write big, so it's gonna be integration over C. You have a function f x y, right? So I write f x y now. It could be in three-dimensional. It could be x y z, right? And it could be d something. Right. So when I say it's consists of three parts, this is part one, this is part two, and this is part three. All right. So let's go over each one of them, and the theme is like you're gonna when you compute line integral, you're gonna go over one by one, and then you're gonna transform one by one to the form that you can compute. All right. Let's go over the middle one first. F. This is just a function. We integrate over what function, we just put it there, right? For line integral, there will be a little bit of chain we have to do to this, but not too hard, right? The one is the curve we are integrating over, and the d is the variable. All right. So for the starter, um, there will be three types of basic d. we can do dx, dy, and ds. Okay. I'm gonna show you how to compute each one of them one by one. Okay. But that's the basic. We have integral, we have function, we have the d. The d can be one of the three cases, and the key is we will transform each one of them one by something called parameterization of c. All right, so we're gonna look at the integral, and then we're gonna look at the c that given to us. The ct will be a function, and this is called parameterization of c. All right, so whatever it is, right? So the thing is, ct will be some sort of like a function that you plug in t, you get a value. So the picture is gonna be like this if you have something like this, right? The way you should think of ct is like um, ct is a function that when you plug in t, you get a point and it runs from a to b. So if you plug in ca, you get this point, and as you increase your value of t, you're gonna keep moving until you got to this point. At this point, it's gonna be c of b, kind of like this. Okay, but the picture aside, what we want to do is we want to transform. Okay, so let's do one by one. Okay, we're gonna refer to this picture. Okay, that like the integral consists of three parts: the one, the two, and the three. The one, integration of c. Oh, I forgot that like um oh. All right. So what you want to do is you want to look at this formula in every line integral problem. They'll give you this. They'll give you the formula for the c, which has the first part and the second part, and then the range of t. All right, and it kind of follow this picture. All right. So what you want to do with the one is that integration of c, you're just gonna change it to integration from a to b. Right? The integration of C, we have no idea how to do. But eventually, if we need to do integration from A to B, that should be pretty easy, right? Because you just integrate and plug in A and B. All right? So that's one. For the two, you have a function f, right? What you're gonna do is, this is gonna look confusing, but it's actually pretty easy in terms of computation, right? But right now, what you're gonna do is, instead of writing x and y, no more x and y. Every time you see x and y, you're gonna change it in terms of t, and you're gonna use this formula, right? These x and y in terms of t will tell you what you need to plug in for x and y, right? So it's gonna be fxt, fyt. Like for example, if ct is like t squared here, you just plug in t squared here. if y is 1 over t, you plug in 1 over t here. And all of a sudden, you will not have x and y anymore. All right? So let me write it down. In other words, we replace x by xt and y by yt. All right? Bada bing, bada boom. No problem. All right? And last but not least, number 3, the d. All right? The d has 3 cases, right? So we have either we have dx, dy, ds. All right? The way I remember this is when you see d is like differentiation, or d is diff, right? If you see d, you diff, right? So you see dx, you just differentiate x become x prime, dt, right? And where do you get x? Well, you get x by the same formula up there, right? You differentiate that, you get x prime t, and then you multiply by dt. And then we do the same thing, right? dy, what you're gonna do is you do y prime t dt, and then for the ds is the annoying one. Ds, let me tell you, this is like you integrate by arc length, right? If you want to understand the detail, you can talk to me afterward. But the idea is like the measurement that you use is the length of the arc that you're traveling. And the formula is annoying. You need to do x prime, you need to do y prime, you need to square it, and then you do dt. All right, so that's a big formula to do, right? You differentiate x, you differentiate y, square, add them up together, and put in square root. All right, so you combine everything and then you integrate with respect to t. All right, so let's see some example. All right, so the problem could look like this, right? I give you a function, and I give you a c, and ask you to integrate. Haven't write down the problem yet. So you find integration dx, integration dy, and integration the same thing fxy ds. Okay. Okay, so a problem can be like this. I give you a function, I give you a curve. When you see a curve, you box it. You will need to use it. Okay, you need to use it, and then you integrate with respect to x, with respect to y, with respect to s. Right. So whatever it means, let's do it. So how do we start here, right? So let's start with copy this down, right, and box it because we need to use it very often. All right, and let's start off with integration c f x y dx. All right. So for the first one, I'm gonna do it step by step. Okay, I'm gonna do it one by one. All right. So integration over C will become integration from 1 to 2, right? Because the range of t go from 1 to 2. So when you have integration, you go from 1 to 2 like this. Fxy is from the formula is x squared plus 2y squared, right? But we're not gonna do x squared plus 2y squared because we're gonna change every single thing to t, to this variable t, right? So what we're gonna do is this, right? So we look at this and then we see this is x. Every time you see x, you're gonna see no more x. Gonna replace x by 2t. The same thing here. We're gonna replace y by t. All right, so the result would be like this: x by 2t, right? Y by t. And then what's happening? 2t squared become 4t squared, right? Remember the square distribute inside. 2t squared is just 2 of t squared. So in total, we get 6t squared. And last but not least, dx will be x prime dt, right? But we know that x equal to 2t. If you differentiate 2t, t become 1, 2 stay as 2, right? So it's going to be 2 dt. We got 3 information, and then we conclude this, that integration over C of function f x y dx will turn into integration from 1 to 2 because we get the first part right there. Fxy will become 6t squared and dx become 2 dt. All right, I hope it's clear what's going on here. You just go from left to right, and each step you kind of do things a little differently each time. All right, and after this should turn into a mathematic 1 problem, which is just integration over one variable. So what do you have? You have integration from 1 to 2. You have 12 t squared dt. 12 t squared become t3 over 3. And then you plug in 1 and 2. And then you get 4, 2, 3 minus 1, 3. And the answer will be 7 times 4, which is 28. Right? So I hope I got it right. Okay, so that's the basic of line integral. You transform each one of them, and then you integrate in one variable. All right, so let's do integration dy too. All right, let's copy this down too, because no matter what we do, we're gonna have to use this very often. Okay. Okay, so usually what I do is I don't write down thing on the side like this because it's a waste of time and space. So I just gonna do like this. And then just gonna do it one by one, right? So integration over C gonna be 1 to 2, x squared plus 2y squared gonna be 2t squared plus 2 of t square. And as at this point, you probably realize that the first part is the same on both problem, right? But dy though is a little different. Y equal to t, so y prime equal to 1. So you get 1 dt here. And remember, when you multiply by 1, you multiply to the whole thing, okay? All right, so integration from 1 to 2. This one gonna be 6t squared dt. All right, I'll let you complete the rest by yourself. But if you notice, the previous one you get 12t squared, this one you get 6t squared, so answer should be half of the previous one. But if you want to integrate by yourself, the answer right now is 14. All right, wonderful. Right, let's do the last one, which is ds. All right, so here's the thing that we're gonna do. X prime equal to 2, y prime equal to 1, right? ds, we need to use both. We need to use square root of x prime square plus y prime square equal to square root of 2 square plus 1 square, which is root 5. Okay, so integration over c will be integration from 1 to 2. F will be, as we know already, is like 2t square plus 2 of t square. Everything multiplied by ds, which is square root 5 dt. Right? Whatever you get from this square root, you put in front of the t. All right. Again, I'll let you complete it by yourself, but the answer should be 14 times square root 5. Bada bing, bada boom, that's it. All right, so that's a basic of integration, line integration, but that's not all, okay? Because sometimes people don't like to write it as dx dy. People like to combine it, right? Sometimes, all right, you see very often that like people just gonna go to you and like, oh, can you compute this integration over a curve p dx q dy? And you will confuse like, what the hell is going on? Usually we do integrate something dx, usually we do something dy, but now we have something dx, something dy. What do we do, right? So this looks scary, but this is just integration over c p dx, done one problem, and then you do another problem, integrate over c q dy. All right, so it turned out that if somebody gives you a problem that look like this, they just give you to do 2 separate problems and just add up together at the end. All right, looks scary, but not too bad. Okay, so let's do one more example on that. All right, let's compute the following line integral. Integration over c of 2xy dx plus x squared plus y squared dy. Right, and when somebody give you a line integral like this, they better give you a line too. So when x equal to cos t all right, so it could be something like this. Okay, so they give you integration, they give you x and y. Note that this time they don't give you the c, they give you x and y, which is easier. This is equivalent to saying ct equal to cos and sine, right? And then we have the range of t. So now we don't have any problem, we just go ahead and do the problem. All right, so let's do this problem. All right, so what are we doing here? We're going to integrate this function, right? So first of all, we're going to go from left to right and transform one at a time. Integration over c, um, you look at the range of t and then you put it as the bound. Okay, and then you have 2xy, right? So let me just copy this. And say that, oh, you have 2x. You don't say x anymore. You every time you see x, you put it as cosine. And you see y, you're like, no, we're not gonna do y, we do sine. All right, and then you see dx, and remember, dx, d mean differentiation, right? So you tell yourself, okay, x equal to sine, x prime is minus cos, x equal to cos, sorry, x prime equal to minus sine, right? So I'm gonna multiply by minus sine t. All right, and notice that instead of minus sine t dt here, I'm gonna save dt for now. Gonna put dt at the end. So for now, what I want you to see is I want to see you to see that this is the x, this is the y, and this whole thing is dx. Right? Not quite, because dx gonna be that thing times dt, but as I say, dt we're gonna save it all the way to the end. All right, and then what happened next? We have plus x squared plus y squared. Okay, so um, cos square plus sine square. dy, y is sine, you differentiate sine, become cos. All right, and all in all, you have dt all the way at the end, right? You can think of this as like this is dx, so you have differentiation dt, and then cos, you have like this is the y, right? So differentiation of sine become cos dt, right? So we kind of pull dt all out at the end instead of write dt here and dt there. Right, so that's what we're gonna do with when we see a problem with something dx, something dy. We're just gonna go from left to right, replace things one at a time, and then put dt at the end. All right, so let me write down that this is x, this is y, and this is y prime. Okay, so what do we do next? You have integration from 0 to pi over 2. All right. You have 2 of, with the minus sign, sine square cos. And if you don't know already, sine square plus cos square, no matter what angle it is, it always be 1, right? So this thing all the way be 1, so we just left with cos here. All right, and I'll not go much into the detail, but the first part here, we use something called u substitution. Let u be sine, and then this is going to be part of du, right? So at the end, we're going to get 1/3 of sine square. I mean sine cube. Integration of cos, this one is easy. Integration of cos becomes sine. And then you plug in from 0 to pi over 2. All right, I'll let you figure out how to plug in by yourself, but just so you know that sine of pi over 2 is 1, right? So after you plug in everything, oh, sine of 0 is 0 too. So you plug in everything, you get this plus 1. So the answer is 1/3. All right. So before we end this clip up, let me tell you one more thing. Okay. So sometime the problem tell you the parameterization like this. That's nice. You can just use it. Sometimes tell you parameterization like this, which is cool. We can use it. But what if the problem doesn't tell you the parameterization? They just describe to you. So what do we do? Okay. All right. So sometimes the problem just describes you, oh, CT kind of look like this, right? And then you have to kind of figure out by yourself. So that's sad, right? But that's not the end of the story because we can construct it ourselves. And I'll teach you one way, right? There are so many ways. There's like parameterization by using like x as one of the variable. There's circle. The one I'm gonna teach you is straight line. All right, we're gonna construct a straight line from A to B, so kind of like this. So if you have like a point A here, a point B here, and then you ask like, what is the way to travel from here to here? Like straight line. We go around. Um, we don't go past and come back. We just go straight line from A to B. All right. So if you want a straight line from A to B, we do CT equal to um, A plus 1 plus B minus AT. All right. You can try to imagine what happened if you try to plug in value to. If you plug in 0, 0 will go here and then it will kill here. So at 0, you add A, right? If you plug in 1, it 1 here and this A will cancel with this A and then you end up with B. So you are here. Right? So when you plug in 0, you add A. When you plug in 1, you add B. So you plug in anything between, you get a line, right? So the parameterization will be 0 and 1 go around the T. All right. So example would be like this. Find a straight line that start at 1, 2 and end at 5 minus 2. Okay. Um, when you see like this, what we do, we just say that this is the A, this is the B, right? A is the start, B at the end. So you see CT equal to A plus 1 B minus AT, right? So we get 1, 2 plus 5 minus 2 minus 1, 2 T. So you get 1, 2, and then you subtract and add vectors, just like we did in the first half, right? So 5 minus 1 is 4, and then minus 2 is minus 4. And then you have 5 and then minus 2t. Oh, no, sorry. The way you do is you distribute t inside, right? So we get 1, 2 plus 4t minus 4t. So at the end, you get 1 plus 4t and then 2 minus 4t. All right, and that's the end, right? You get CT from here, and if you need to integrate this function, um, if you integrate any function over this C, you're gonna use this as x, use this as y, and then plug in the f, do differentiation. X prime will be 4, y prime will be minus 4, so on and so forth. Okay, so that will be it for the first part of line integration. We will continue the next part of line integration and equipped with some of the theory that you need to know for the line integration. But for now, bye bye.